Yeah, about skewness preference. Skewness preference means that investors have special preference for extreme probabilities. Extreme probabilities. So, for example, there was an experiment such that people, researchers asked question to people like this. It is a horrible question, but in researchers asked a question such that suppose you have a kid and your kid is about to die with 100% of the chance, so will die certainly shortly, but there is a pill, there is a drug, and if your kid take the drug, your kid have 1% chance of survival and 99% chance of death. Then the question is how much money will you willing to pay for that 1% chance? So what is your guess? What would be the people's response about the money? Yes, so even you're absolutely right. Even for the small chance, like 1%. So 99% chance of dying is dying for certain, almost certain, right? But anyway, since there is 1% chance of survival, the respondent said they will pay enormous amount of money for 1% chance. And they also asked another question. Now, suppose your kids have another horrible disease. Now your kids will die with probability of 99%. And again, there is a drug, there is a pill, and if your kid take the pill, then now again there is 1% chance of improvement. So now your kids have 2% chance of survival and 98% chance of death. Then how much you willing to pay? And then the respondent says that still they will pay a lot of money, but not as much money as from 100 to 99%. So it is the same 1%, but there's a qualitative difference between 100% and 99%, and between 99% and 98%. So there is a qualitative difference. And then besides these horrible questions, researchers made different versions of many variations of question, and the answers are almost the same. There is still jump from 100% to small chance of something, and then yeah. So immediately people have special preference for probability when probability is very close to 100%. Actually, there is another version. People have also special preference for very small probability, from 0 to small chance of something. So suppose there is a construction project. And then there is some government project, and the project will increase the GDP of a country like $100 million, so which is a lot of money. But if the government does the project, then there is chance that like 10 people will die. Then the question is whether the government should do the project or not. And then many respondents said that the government shouldn't do the project. Right? And then there is another version of the question. So again, there is increase of GDP is like $100 million, and then people will die additionally, like 10 more people, something like that. So certain like every day 100 people already die, and then if they do the project, like 10 people more die, something like that. So they change this question slightly, and now many people support the project. So again, there is qualitative difference between people never dying and then 10 people die, and 10 people die and 20 people die, something like that. So there is again qualitative difference for very small numbers. So that is called skewness preference. It is well-known behavioral bias. So let's suppose people have such a preference, skewness preference. People have special preference for very small probability. Then What would be people's behavior in stock investing? Can you guess? I mean, if people have such kind of skewness preference, that preference should appear in stock investing as well, right? So, what kind of situation do you think will that kind of preference will emerge? Any guess? So there are some stock like lottery. Lottery is example, right? If you think of lottery, if you win the lottery, then you will make a lot of money. But the probability of winning a lottery is extremely small, right? It is almost close to zero, but not zero. If it is exactly zero, then no one will buy lottery, right? But it is very close to zero. It's not zero, and people have a chance of winning a lot of money, and then people are willing to pay some money to buy the lottery. So buying lottery is one example of preference, skewness preference. And then there are stocks which is similar to lotteries. Some stock has a very chance, some stocks have a very small chance of going up a lot, but the chances may be very small. Or some stock has a very fat tail in one side, something like this. So if we have a normal distribution, it is for normal distribution, it is symmetric. Left hand side and right hand side are symmetric, right? But there are some skewed distribution, something like this, maybe. Let me give you more skew. So there is some probability maybe look like this. Yes. Something like this. Oh, this figure looks like the little prince, the snake swallowing elephant, something. No, anyway. Anyway, if you look at this distribution, how is it? It is negatively skewed or positively skewed? How we can say? Beg your pardon? Right skewed. So right skewed right. Yes. Yes, exactly. It is rightly skewed, or we say it is positively skewed. Yes, because this side, this way is positive. This is positive or negative. And it looks like there is a lot of probability mass on the negative side, but actually it is not true. There are very long tail on the positive side, so there is a small chance that very large number happen, right? So this is called positively skewed. And then this kind of skewed distribution of property, mean and median are very different. For example, like median is somewhere here. It is like, this is not good. So maybe this is a median. In statistics, median is the place where the size of this area and then size of this area is same, then it is called median. But the mean is somewhere here. It's a mean, right? Median is a size. Mean is like a squared distance. So if you have a very long tail on this side, because it is squared, no, it's not squared, actually. So anyway, because this one has very large number, and we multiply probability to this large number, which means that this one, very large number, receives some weight. Therefore, mean tends to move this way. Okay, so in case of positively skewed distribution, mean is greater than median, and if there is a negatively skewed distribution, then mean is less than median. And if we have a lot of skewness, then mean and median are very different. So distance between mean and median is one way to measure the skewness. And then people have a preference for this kind of distribution when mean is much greater than median. And then this is exactly like a distribution of lottery. Very small chance of winning a lot of money. So there are some stocks have this kind of distribution. Okay? And people have a preference for that kind of stocks. Okay, so there are investment behaviors like as we discussed, like insufficient diversification, excessive trading, disposition effect, performance chasing, and security preference. And psychologists and economists, behavioral economists, found what psychological mechanisms explain this investment bias. So for insufficient diversification, maybe ambiguous aversion familiarity. For excessive trading, overconfidence, sensation seeking. For disposition effect, prospect theory, loss aversion, mental accounting. And performance chasing, excessive extrapolation, hard hand fallacy, representative, and cumulative prospect theory. I explained everything except prospect theory and cumulative prospect theory. They are very important concepts in finance. But since we don't have enough time, so I'll just skip this part. But because this is so important, if you have time, please Google prospect theory and cumulative prospect theory, and then study yourself. And they are actually very fun theory, very interesting theory as well. So, and then behind this psychological mechanism, people also find there is a gene, which I have no idea, but there are some genes that is related to this psychological mechanism. And this paper want to investigate how, so people already found that gene is at the basis of gene may cause psychological mechanism, which in turn investment biases. People already know that, but this paper is more quantitative. They want to measure how quantitatively these genetic factors matter in determining investment biases. So they collected data about twins, but thing is that not many countries collect investment behaviors and those information about twins. But interestingly, Sweden has that kind of data. So they got the data from Sweden. Our data set is constructed by matching a large number of twins from the Swedish twin registry, the world's largest twin registry, with data from individual tax filings and other data set by Statistics Sweden. So anyway, Sweden is a very interesting country. I don't know why they do that, but they collect data about twins very systematically. Very interesting. Okay, they do that. So the researchers match the twins data, the twins with portfolio and sales transaction data between 1999 and 2007. So it's a completely reasonably long data, providing us with detailed information on the investment behavior. And then measure of investment. But now next the question is, okay, since their hypothesis since their research question how much genetic factors matter for investment behavior, so they have to operationalize investment biases, right? They have to measure, they have to define how they have to determine how they can measure sufficient diversification, excessive trading, and disposition effect, something like that. Like excessive trading is straightforward, right? We can simply count how people trade per day, something like that. Or turnover, total number of shares and total value of trading, then they have like turnover. So it's easy. But for others, like insufficient diversification or like security preferences, they are slightly more tricky than the others. So they have to determine how to measure these things. So in order to measure those investment behaviors, what they also did, they checked the other papers. There are other papers about those things, and those papers measures this investment behavior. So basically, the authors apply other papers. idea. Other finance papers about this investment behavior, and they measured this one, and they compared the investment behavior between twins and across twins, and figure out how much they matter. So for the diversification, they measure diversification as the number of distinct stocks held in an individual's portfolio at the end of a given year. So which means that if there are a lot of distinct stocks in a portfolio, it means there are high level of diversification. If there is a small number of distinct stocks, it is low level of diversification. Another idea is for holding stocks in a mutual fund. They follow this paper and define diversification proportion of equity investment invested in mutual funds as opposed to individual stocks. So it means that if many people hold the more individual stocks than mutual fund, it means they are less diversified. If people hold more mutual fund than individual stocks, then they are more diversified. And turnover, next, turnover, which is easier. It is measured excessive trading, whether people trade excessively or not. And therefore, turnover, an individual propensity to trade and turn over the portfolio, and they measure the turnover following Barber and Odin, which is a very famous paper. Specifically for direct stock holdings, we divide for each individual investor as an year the sales volume during the year by the value of directly held stock at the beginning of the year. So basically, sales volume divided by number, so like turnover. And then disposition effect. Again, to remind that disposition effect means that people tend to hold, the holding period tend to become longer when stock price go down, okay? And holding period tend to be short when stock price go up, because people hate realizing their loss, recognizing the loss. Therefore, the holding period tends to become larger, longer when stock price performance is bad. So how we can measure this kind of disposition effect? Specifically, at the end of each year during which we observe a sales transaction, we classify security in the investor portfolio as winner and loser based on security price relative to the approximate price at which the investor acquired the security. So the idea is simple. At the end of the semester, they classify stocks into two groups, the winning stock and losing stock. Winning stock means the stock price went up. Losing stock price went down. So we have two groups, winning stock and losing stock. And they check how many winning stock they sell and how many losing stock they sell. And they check the ratio. If an investor is rational, the ratio should be close to 1, right? The selling decision should be independent of past performance, basically, right? Selling decision should be correlated to future prospect, not the past performance. So if individual is rational, then the ratio should be close to 1. But disposition effect means that this ratio is much greater than 1, right? Because people sell more winning stock than losing stock. So the ratio is basically a measure for disposition effect. And then how about the others? This is the summary statistics, and then performance tracing. Okay, performance is how to measure performance tracing. Well, this is easy, maybe. For some stock, for every stock, we can maybe sort stock based on past performance. So top 10% in terms of past performance. So top 10% stock means their performance were very good, and maybe bottom 10% performance were very bad. So we can measure for each twins account. Maybe you can measure how many stock a particular person bought in the top 10 group. Okay, and how many stock they sell at the very bottom 10%. Then we can measure performance tracing. Right? Does it make sense? And then skewness preference. For skewness preference, we can first, it is again not so difficult. We can first figure out which stocks are close to lotteries. Okay, so we can select stocks which close to lottery, and then for each person's account, we can check what is their portfolio weight for that lottery-like stocks. If a person bought a lot of lottery-like stocks, then it means the person is subject to skewness preference. If they don't, then they are not. Okay. So this is skewness preference. And then so now, yes. And then once they measure all these investment biases, then they maybe calculate the weighted average of these investment biases, and then we can measure total at individual the investment bias index at the level of individuals. Okay, so again we can measure all those investment biases and we can sum them up, and then we can have one number for each person, the investment bias index. And if the number is high, then the person has a lot of investment bias, and if number is low, then the person has low investment bias. Right? Make sense? Okay, so we are almost done. And then now they collect twin data. So there is a kind of different mathematics, and then different mathematics, matrix algebra, something like that. But the intuition is like this. Yeah, actually, this mathematics is not difficult, but actually, the intuition is okay. So there is a twin. Okay, there is a twin. So this is maybe identical twin. Okay, identical twin. But there is also fraternity twin, not identical twin. By the way, do you have any twins? Is there any twin in this class? So there is non-identical twin, and then there is another ordinary. That actually twins are also ordinary people. How can I say that? Non-twin. Okay, there are non-twins. How can I draw non-twins? Okay, X is non-twin. So X. Okay, so identical twin, fraternity twins, non-identical twin, and non-twins. So investment biases are determined by what? The individual factor, like genetic factor, and then another one is environmental factors, and third one is like education and individual specific factors. If we compare twins and then these non-twins, and they are genetically different, and their environment is different, and their characteristics is different. If we compare between this and this, and they have genetically, first their environment is maybe similar, right? Their environment is maybe similar because their parents are same, and they have lived in the same house. So of course, environment is not exactly the same, but their environment is likely to be similar than other non-twins, right? And about genetics, for identical twins, their genetics is the same, but for non-identical twins, their genetics is 50% matching. So they are exactly the same, and for this they are same for everything, and for this one they have 50% and they are same, they are different. Okay, actually they are different in this factor as well. And for this one, they are different for everywhere. So if we compare this and this, then we can all the differences derived by this one and this one. And if we compare these two, then we can separate out the genetic factors. We can separate out the genetic factors by comparing this and this. And if we compare this and this, and we can separate out genetic factor plus environmental factors. Right. So basically, idea is there is three factors that determine investment biases: genetic factors, environmental factors, and individual factors. And basically, we have three couples, and therefore, basically, it is like we have three equations and three unknowns, so we can identify everything, at least statistically. So basically, that's the idea. Yeah. Does it make sense? So yes, so that's the idea, and then if we express it mathematically, we have this one. And then the result is very interesting. So this is the graphical representation of their result. So this is the x-axis is the class of investment biases: diversification, home bias, turnover, disposition based performance change, skewness, preference. And then y-axis is correlation, and then we have identical twin, fraternal twins, same sex, and fraternal twin opposite sex. Okay, so we have a spike, we have long bar, which is identical twin. So identical twins have a higher correlation between each other than other twins. So this one directly shows that genetic factors matters. Right? For other twins, we have fraternal twins on average, and there is basically no statistical difference between same-sex fraternal twins and opposite-sex fraternal twins, right? And in some cases, actually, like a disposition effect, there is actually even higher correlation between opposite-sex fraternal twins, actually. So gender actually doesn't matter, okay? Genes, okay? Genetic factor actually matter more. So genetic factor actually drives more like drive the result. And in particular, if you see like diversification and home bias, we have like close to 50% of correlation for this one, so which is very high. And then like disposition is slightly low. So we have a particularly large correlation for diversification and home bias. I think the time's up. So do you have any question about today's topic? No. Okay, again, let me remind you, because it is important, so remind you again of our class schedule. So please note on your calendar that we will have a supplementary class on June 8th, okay, June 8th, and then it starts from actually 4 o'clock, right? It is from 4 to 6, and I will let you know the classroom shortly. Okay, thank you, and see you on Friday.